Kia ora, Year 12 and 13. This is question 2E from this year's Differentiation Level 3 paper. So I quite like this question, but I think it's much easier if you know a technique called implicit differentiation. So I'm going to first do this problem using implicit differentiation, and then I'm going to do it a different way because I know that some schools probably don't teach implicit to Level 3 calc. If you're watching this and you're doing scholarship calc, I'm pretty confident that you will know how to use it and you'll see straight away why it's useful. So here we've got a curve. It's not a function, right? It's a curve. Here it is here. And it's got this equation. So it's a parabola. And again, if you're doing conic sections, which is one of the level 3 standards that's not that common, you'll be pretty confident with this curve equation here. Anyway, the curve has got a tangent of gradient 1 at point P. So this is point P here. And obviously we're going to have to figure out where that point is. We're told that the tangent intersects the x and y axes at points R and S respectively. So let's grab our ruler and draw on roughly where that tangent is going to be. Now, so assuming that the scales are the same, which is always good, we know that the tangent, oh, look, it tells me exactly where it is. Let's try and draw that line in now. Oh, well, that's not quite a tangent, but it's pretty close. Okay, so here's point P, and it intersects the x-axis at point R, which is here, and the y-axis at point S, respectively. And what we have to prove is that the length RS is 7√2. So steps to solve this problem are 1, we're going to find P, 2, we're going to find the tangent equation, and 3, we're going to find the x-intercept and the y-intercept. So we're going to get the coordinates of this point and the coordinates of this point, and we're going to use Pythagoras to get the distance between the 2 points. So it's not too bad once we find point P, and to do that we need to differentiate this curve and figure out where the gradient's equal to 1. So first up, I'm going to do this using implicit differentiation. If you're watching this and you don't know what it is, I've done a couple of videos on it. So let's just start off with what this curve is. So I'm going to differentiate with respect to x, but this is something in terms of y. So I'm going to use the chain rule, and I differentiate it with respect to y, and we get 2 times y minus 5, and by the chain rule I'm going to times out dy by dx. Again, I'm not teaching implicit here, so I'm just going to use the method. It's a really cool method, but go watch the video if you want to learn it properly. Okay, and then here, this function is 16x minus 32 on this side. So differentiating this with respect to x gets me 16. Again, if you're watching and you've got no clue what's going on with the weird chain rule thing here, hang in there because I'll do it a different way in a minute. So now we get dy by dx is equal to 16 over 2 times y minus 5, which is just 8 over y minus 5. Now, what do I know at point P to be true? Well, point P is where the gradient is 1. So we're going to set this derivative equal to 1 and solve. So we get 8 is equal to y minus 5, giving us a y value of 13. And now I have to figure out what x is. So we go back to the original curve, which was y minus 5 squared is equal to 16 times x minus 2. And I'll substitute in 13. So going really slowly here, 13 minus 5 squared is equal to 16 times x minus 2. 13 minus 5 is 8. 8 squared is 64. 64 divided by 16 is equal to x minus 2. So x is equal to 4 from here, plus 2, which is equal to 6. So point P has got the coordinates 6, 13, and at point P, the gradient of the tangent is 1. So now we can find the so let's just go back up and have a look and see if that makes sense. Yep, that looks about right. Okay, so there's the point 6, 13 there. Right, so moving on, the next step is to find the equation of the tangent, and I'll use y minus y1 is equal to m times x minus x1. That gives me y minus 13 is equal to x minus 6 because the gradient is just 1, giving us the equation y is equal to x plus 7. Now that's starting to look good, because remember, I'm trying to show that the distance between these 2 points is 2 root 7. So point R, which is, what's point R? Which one is it? Point R is this one here, and point S is this one here. And we can see very quickly by looking that R is equal to -7, 0, and S is equal to 7, 0. This one, that's not right, 0, 7. Sorry, time for another coffee. 0, 7 here. And so the distance RS, let's just draw it out. Here's R, here's the origin, and here's S. This distance is 7, and this distance is 7. So RS squared by Pythagoras is 7 squared plus 7 squared, which is 98, which is equal to 2 times 49. And that means that the distance RS is equal to the square root of 2 times 49, which is equal to root 2 times 7, which we can write as 7 root 2 as required. Now, some of you are probably watching going, when is she going to teach us the other way that doesn't use the thing that we never learned, right? And so the other way to do this is to look at the curve and say that what we'd like to do is to get y as the subject. So instead of working with this thing like this, we're going to get y is equal to blah, blah, blah. So there's one issue with that, which is that obviously there are 2 bits of y. Not 2 bits of y, there are 2 bits of the curve, right? So there's this bit of the curve, which is the top branch, and then there's, change colour, this bit down here, which is the bottom one. Clearly point P is on the top half of that curve, and that's going to help us here. So starting out from what we've got y minus 5 squared, I think. Yep, y minus 5 squared is equal to 16 times x minus 2. I'm going to take square roots of both sides. Y minus 5 is equal to plus or minus this. So y is equal to 5 plus or minus the square root of 16 times x minus 2. But we know that we want the top branch. So our part, where point P is going to be, is y is equal to 5 plus or minus 4 root x minus 2. And I'm going to write that with a fractional power. Sorry, that shouldn't say plus or minus anymore. That should just say plus for top bit of curve. That'll do. Now, what we're going to do from here is we're going to differentiate that and figure out whether gradient's equal to 1. So you've just got to do a bit more work before you do your differentiation, but the differentiation should now be really comfortable with no need to use implicit. Differentiating, we're just going to use the chain rule. So it's going to be 4 times 1/2 x minus 2 to the negative half, and differentiating the inside function just gives me 1. So that's very easy, hardly even the chain rule. And so now I've got 2 over root x minus 2, and I need to figure out where that's equal to 1. Okay, so 2 is equal to root x minus 2, 4 is equal to x minus 2, and x is equal to 6. And then from there, off we go, we chuck this back into here, and we figure out what y is. So, and from that point on, the question is exactly the same, right? It's just how we got to finding point P. Now, personally, I would always do implicit if I can. Once you know it, it's a wonderful method. But I think that rewriting that equation as y equals is also pretty accessible if you're aiming for excellence in level 3 calc. So I really like this question. Probably one of my favourites in all 3 papers. If you've got any questions on it, just leave me some comments. Thanks for your requests. I'm seeing a couple for some complex numbers merit ones, so I'll get onto those once I've done question 3E.